Hi there, welcome to Module 3 on relations and functions. In this lesson, we will uh, talk about what a relation is and what a function is. And we'll look at a few examples of what a function is and how to represent a function. First of all, what is a relation? A mathematical relation is a correspondence between two variables, any correspondence between two variables whatsoever. And these are generally represented with numbers. And we're going to see examples of those. You will remember what a variable is. A variable is something that can change. That's why you call it a variable. It varies. It can take on different values. That's what a variable is, if you remember. And generally, we represent variables using x and y. Now, you can use other letters as well, but generally, standard, we use x and y. And x carries a meaning with it, which we're going to talk about, and y variable also carries a meaning with it that we're going to talk about. So, for example, here is a relation. I have represented it in tabular form. I have a column for the x variable and I have a column for the y variable. And what this relation means is that -1, so the x variable, when it takes on the value of -1, it's related to 7. -1 is also related to 2. -1 and then 4 is related to 0. And 0 is related to 3, so the variable 0 as x is related to the variable 3 as y. The variable 6 is related to 3. And finally, the x variable 5 is related to the variable 4, the y variable 4. This tabular form, this relation that I've put in tabular form, can also be expressed as ordered pairs, as x, comma, y. Now, this x, comma, y, you can represent as -1, 7, -1, 2, 4, 0, 0, 3, 6, 3, 5, 4. This is how ordered pairs are represented. They are always represented as x coordinate, comma, y coordinate. And they are put in bracket in this way. I have represented this relation in two different ways. Now, I have tabulated it and I have also represented as ordered pairs. I can also draw the graph of this relation as shown. The first point in there is -1, 7. So you can see that point there. On the x-axis is -1, and on the y-axis is 7. And then you can see the next point, -1, 2. And you can see the next one, x is 4 and y is 0, is right on the x-axis. And you can see another one, x is 0 and y is 3. And you can see 6, 3, when x is 6, y is 3. And finally, you can see 5, 4. This is the relation that I've described. I've now represented that relation in three different ways. I've tabulated it in two columns as x, y, as x and y variables. I have also represented as ordered pairs, and I have also graphed that relation as well. Now, here's what we had previously. We had our relation in graphical form as ordered pairs and in tabular form. Now, what is a function? A function is a relation that has a special characteristic. It has a special condition attached to it. What is this condition? The condition is that there is no one x variable that can be related to more than one y variable. Now, you have to pay attention to that. If you look at my tabular form that I have here, you see that -1 is an x variable. But you see, -1 is related to more than one y variable. -1 is related to 7. The same -1 is related to 2. That means the relation I have here is not a function because it has this condition. It breaks the condition that a function must not have. A function must not have a single x variable related to more than one y variable, which this relation does. In graphical form, this condition that a function must not have is represented as a vertical line that cuts through the problematic points. You can see if my vertical line that I've drawn here, you can see it goes through these 2 points, -1, 2 and -1, 7. There's a vertical line going through them. That means the set of points that we are talking about is not a function because it's breaking that rule that a function must not break. It's a relation, but it's not a function because you have a single x variable being related to more than one y variable. Now, again, here's what we had previously. We had our function in tabular form and also in graphical form. If we want this relation to be a function, we have to make some adjustment here. And the adjustment is this. We have to take out the problematic point. The problematic point, -1, 2. We have taken it out now. Or we could have taken out -1, 7 and left the other one in there. The point is, you cannot have one x variable being related to 2 different y variables or more than one y variable. So if we take out one of them, then we have a function. So the graphical form and the tabular form we have now does represent a function. Here is the graph. The graph of the function is on the right, and you have the tabular form on the left. And you can see that the offending point has been removed. Now, perhaps you are wondering, if you look at my tabular form there, you can see x is 0 and is related to y is 3, and x is 6 is also related to y is 3. Now, that one is not a problem because that's not the condition that a function must satisfy. You can have 2 different x variables being related to the same y variable. What you can't have is one x variable being related to more than one y variable. I hope you can tell the difference. So now, let's do a little quiz. I hope you like quizzes. It's a short quiz and I'll help you with it. Okay? Try and identify the relation that is also a function here. Look at this one. What do you think? Take a moment and think about this. Do you think this relation is a function or not? If you are thinking about the point -5, 4 and -5, 2, you're on the right track. Because those 2 points, you can see that the point -5, x is -5, the same point is related to more than one y variable. It's related to 4. It's also related to 2. So you are correct. This is not a function because of that condition. What about this one? What do you think of this one? Is this a function? This relation, is it a function? Take a moment and think about this. Perhaps you are wondering about the point 4 and -3 and 0 attached to -3. Now, we said that's not a problem. A function can do that. And you can see that that happened in the previous example as well. 2 was attached to 0 and 4 was attached to 0 as well. Now, that wasn't the problem. The problem was -5. In this example, in this next one, 4 being attached to -3 and 0 being attached to -3 is not a problem. You do not have a single x variable being attached to more than one y variable. So again, you are correct. This one is a function. Let's look at one more. Look at this one. What do you think? Do you think this is a function? Well, you can see that the condition that we talked about is not present here. even though you can see that all the x variables are attached to a single y variable. That one is fine. What must not happen is a single x variable being attached to different y variables. So again, you are correct. This one is also a function. The last thing we will talk about before I give you some practice is some notation for functions. Let's talk about notations here for our functions. Functions have names and they do things. They have things they do. We usually represent functions with small letters. We name them using small letters. Okay, sometimes you use capital letters, but generally you use small letters. So my function that we have described previously, I will name it. I will call it f. F for function is what I'm going to call it. This function relates -1 to 7, relates 4 to 0, relates 0 to 3, relates 6 to 3, and relates 5 to 4. In terms of notation, this function f, we will say that this function f will take a variable x and will give you another variable y. We will write that as f bracket x equals y. And we call this, we will say f of x equals to y. Specifically, the function we have named f now takes -1 and relates it to 7, takes 4, relates it to 0, takes 0, relates it to 3, takes 6, relates it to 3, and takes 5 and relates it to 4. The x variables that this function relates to the y variables, those x variables, you say that is the domain of f. And the y variables to which the x's are related, you say that is the range of f. One more thing. These x variables, there's a specific name for them. They are called the independent variable. Generally, what value y becomes depends on what x is. That is why you call the x's independent variables. And then the y's you call the dependent variables. The value y becomes is closely related to the value x is. That is, y is dependent on x. So what does function f do? F takes -1 and relates it to 7. It takes 4 and relates it to 0. Takes 0 and relates it to 3. It takes 6 and relates it to 3. And it takes 5 and relates it to 4. We will leave it at that for now. In our next video, we will do more notation and we'll take it a step further. But for now, why don't you try and identify the relations here and then name the functions. I'll try and identify the relations that are functions, then name the one that are functions, then find out the domain and range of the functions, and then try and figure out what the function does. As in our previous videos, please pause this video now and try your hand on this example. When you are finished, you can continue the video to see what I have done. So please pause the video now. So what did you do? Here is what I did. Look at the first one here. We'll put it in tabular form. You can see here and look at the numbers that are there, x's and y's. 0 is related to 0, 1 is related to 2, 2 is related to 3, and 1 is related to 5. I hope you caught that, right? You can see that the variable 1 is related to 2 different y variables. Okay, so that is not a function. Look at this next one. The variable x, -4 is related to 1, -3 is related to 1, -2 is related to 7, -1 is related to 0. You can see that this is a function. All the -4 related to 1 and -3 related to 1. That's not a problem because it doesn't break the rule that a function must not break. We will name this function h. I don't know what you named yours. I'm calling mine h. The domain of this function is -4, -3, -2, and -1. Those are the x's that are related to the y's. The range of the function is 1, 7, and 0. 1 is repeated, so we don't need to repeat it. We know that the range is includes 1. And what this function does is to take the independent variable x and relate it to y. Specifically, it relates -4 to 1, -3 to 1, it relates -2 to 7, and it relates -1 to 0. So that's h of -1 is 0. And finally, for this one here, I hope you could see that 2, 2 and 2, -2 are the problematic points there, so that this one is not a function. So this is the end of our first lesson on functions and relations.